Welcome to Mia Maths. Today we're going to learn about quadratics. Quadratic equations or graphs always comes up in your exam, so you need to know how to answer them. To do this, you need to know three things: how to identify quadratic equations, how to solve them, and lastly, how to draw and sketch the graph of a quadratic equation. Today we're going to focus more around how to identify quadratic equations. To identify quadratic equations, there are two ways to do it: visually from a graph, if you see a graph, to identify it, and secondly from the equation itself. Before we go into this, let's really understand how do we know when an equation is a quadratic equation. People have seen, or you should be used to, the equation of a line, which is y equals mx plus c, where m is the gradient and c is the point where it passes the y-axis. Now, if you see an equation in your exam which has x squared plus something 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 something, this x squared makes it a quadratic equation, or makes it a quadratic formula. And that's the difference between a line and a quadratic. So if we see x squared in the equation, you know straight away it's a quadratic equation. Now, what is the general form of a quadratic equation? A general form of line is this: y equals mx plus c. The general form for quadratic equation is ax squared plus bx plus c. We'll go through this in a bit more detail, how to identify a, b and c in a moment. The last thing I want to cover before that is how to visually identify a quadratic equation. If you have a graph and you see this, you know straight away it's a line, and you can use this formula here: y equals mx plus c to solve it, to find out where it crosses the y-axis and the gradient. If you see a graph which looks a bit like this, a smiley face or a sad face with a turning point, these are called turning points, you know straight away this is a quadratic graph. A quadratic graph has only one turning point. This is important because you may see questions in your exam or in other exams which may have loads of turning points. This is not a quadratic graph anymore. So a quadratic graph only has one turning point. Okay, now we know how a quadratic looks like visually from a graph and the general form, and how to identify them if it has an x squared. How do we work out the letters a, b and c? To do this, let's go through an example. So this is an example from a past question. You've got the question x squared plus 3x minus 5 equals 0. You know straight away it's a quadratic formula or quadratic equation because you see the x squared. The next step you do is write down the general form, which is ax squared plus bx plus c. Now you need to identify what is a, b and c. This is easy, but people are very easily to make mistakes in this space. So follow this process. A is just a number in front of the x squared. In this case, there's only one x squared, so it's 1. Next, you do the same process for b. B is just a number in front of the x. What number is in front of the x? A positive 3. So it's just 3. Here, c is just a number on its own. And this is where people make mistakes. People say this is just 5, because they see the number on its own is 5. That's wrong. It's minus 5. Remember, if you see a minus sign next to it, you need to take that along as well. So in this case, a equals 1, b equals 3, and c equals minus 5. Another place people might make mistakes is if they see an equation like this, minus 2x squared plus 6. You know it's a quadratic formula because it's easy x squared. Now we have to find out a, b, and c. We write a general form underneath. Ax squared plus bx plus c. What's a? The number in front of the x squared, in this case minus 2. What's b? The number in front of the x. There's no x there, so what number is it? Because there's no x, b equals 0. And lastly for c, what's the number in front? What's the number on its own? In this case, is 6. That's it. That's how you identify a, b, and c for your quadratic equation. Let's go through a few more examples. Is this a quadratic equation? Yes, you know straight away from visually looking at it. And also for this question, they gave you a little helper. It said it's x squared minus 1. And you know if you see x squared, it's a quadratic equation. This one, this is another form you might see in your exam that is a quadratic equation. Looking at it, you might say, how is it there's no x squared? Well, when you need to solve this question, what do you typically do? You find a common denominator, and to do that, you will need to times 5 by x minus 2 and 9 by x plus 2. Let's do that underneath here. So 5 x minus 2 plus 9 x plus 2 all over x plus 2 times x minus 2, and it's all equals 2. Let's forget about this for a second. The top bit simplifies to 5x minus 10 plus 9x plus 18. The bottom bit simplifies to x squared. Very important to know how to expand the brackets. X times minus 2 is minus 2x. 2 times x is plus 2x. 2 times minus 2 is minus 4. Now you got minus 2x plus 2x, this cancels out. You got 5x, you got 9x, that equals 14x. You got minus 10 and plus 18, which equals plus 8. 18 minus 10 is 8. So all of this simplifies to 14x plus 8 over x squared minus 4. And remember, this all equals 2. Now if we remove these, let's make a bit more space. Let's remove that. What you typically do next is times both sides by x squared minus 4. So 14x plus 8 equals 2 x squared minus 4. Expand this bracket, which is 14x plus 8 equals 2x squared minus 8. Now put them all to one side. Let's move them all to the right. So you have 2x squared minus 14x, because you have to minus 14 on both sides. Then minus 8 minus 8 is minus 16, and that equals 0. Now from a question which didn't look like a quadratic question, ended up to be a quadratic question, and then in this form you go back to your you use a general form again, which is ax squared plus bx plus c. Identify a, b, and c. In this case, a equals 2, b equals minus 14, c equals minus 16, and then you can solve it. We'll go to how to solve these in the next video, but what I'm trying to show you in this one is how you might see a quadratic question mark come up in your exam. Next one, another form, you might get an area of a shape. In this case, 2x, x minus 4, x plus 5 is a trapezium, and you know straight away it's a quadratic formula because it says put the area of the shape in this form, 2x squared plus x minus 351. I won't go how to do that, we could do that in another video, but you know straight away it's a quadratic formula. And again, what you do is write down your general form, find out what a, b and c is. In this case, a equals 2, b equals 1, c equals minus 351, and there you go. The reason I'm reiterating this finding a, b and c because it's very important when it comes to solving the equation, which we will learn a bit more in another video. And that's it. That's how a quadratic question might come up in your exam. That's how you can identify questions that may not look like quadratic questions in the first place, but they actually are. And that's how you find out the letters A, B and C for general form for quadratic equation. Hope you enjoyed this video. If you did, give it a like and a thumbs up, and I'll see you in the next video.